Hello viewers, welcome back to my YouTube channel. Today I am going to start a new course on computer vision, and that we will be doing using Python and OpenCV library. So for that, the all the codings that I am going to do is within the Google Colab notebook so that I can share it through GitHub, and I will share the link in the description below so you can try it yourself using Google Colab. So you don't need to set up any environment locally in your PC. All the codings that I'm going to show, you can do it in Google Colab. Okay. And all the requirements and the installation of the libraries to work with OpenCV, right? Or the Python, you don't need to be worried about that. I'll be showing that in this course. So let's get started. So first of all, I have logged into Google Colab website platform using one of the Google account. Okay. And then what I'm doing is I've created different sections and the codes within Google Colab to show you how I'm going to work with OpenCV library using Python. And for that, we need to first connect with one of the compute engine provided by Google free of cost, right? So you can connect to CPU or GPU based instances of Google Colab. I'll connect with CPU because currently whatever the code we are going to do today will be requiring CPU. Okay, there is no code which requires GPU as of now in this session. Going forward, there will be some codes I'll be showing which will require GPU based compute engines. So for that, we'll change the runtime to GPU based runtime. Okay, so let's continue now. I'll click on connect and wait for some time to get the compute engine allocated for running my code. Okay. If you see here, while it's connecting to compute engine, we'll see here to do any kind of computer vision, we need some machine library and deep learning library understanding, and some part will be overlapping with the artificial intelligence, some part connecting with the robotics. Okay, you don't have to worry about these prerequisites. There is no prerequisite. We'll be starting from scratch, so you'll get to know all these. Okay. So I have given the heading, and then we are starting with the import of OpenCV package. Okay, so let's first run it one by one. I'm importing all these libraries one by one. Okay, this comes with our compute engine, so you don't need to install this uh, in your compute engine specifically. We'll have this already available in our compute engine. And if you see the compute engine, here you see RAM and the disk space allocated to us. Python 3 Google Compute Engine backend, right? Now, if you want to know more about how to work with Google Colab, I'll be providing that link to that course, which is also available on my channel, and you can work with that as well. You can learn how to work with Google Colab, how to write the code, how to do the documentation for the code and everything. Okay. Anyway, let's first check the version of our OpenCV library, and it's 4.7.0. Okay. Here it's for upgrading Python to the latest version. So if we just run it, it will upgrade the Python to whatever the latest version we have. Okay. Now since the new runtime version is Python version is installed, OpenCV Python. Okay. What we can do, we can just restart the runtime. So how we'll do that? Go to runtime and restart runtime. Okay, click yes. Okay. And it's going to restart the runtime. Once that is done, then we'll import one of the image that we are going to work extensively with the help of OpenCV library. Okay. So here, once the runtime engine is restarted, let's first import again these libraries. Okay, and check the OpenCV version now. It's 4.8 now. Earlier it was 4.7. Now let's import one of the image which we'll be using to work with. And let's show that image in the Google Colab. We cannot show it in a window, so we have to make use of matplot library, right? Matplotlib library to plot the image as a graph here. Now, this is the image which we have read from our Google Drive, our storage location. Okay, so there is a folder uh, inside my Google Drive under Google Colab Notebook folder, and I have named it image.jpg, and I'm reading it using OpenCV library, and this CV2 is nothing but the alias name which we have imported here, right? Import CV2, and CV2.im read means it will read the image and store it in the image object here, and then that image is shown via matplotlib library. So plt.im show will show the image, and to show the image as a colored image, we are taking cv2.color bgr to RGB, so that will show the image in RGB, red color, red, green, and blue channels. We will later come to know what are the channels, how it helps to manipulate the image. First thing you know, if it's RGB, then it will show the original colors of the photo. Okay, and that would be basically a colored photo. So here we have seen this colored photo being shown here. So plot.show will show that image now. Okay. Next, what we are doing, we are defining one function im.show so that we don't have to write these 3 lines of code again and again. Okay, so we'll just pass the image and the title to this function, and this function will automatically take those values and run these internal commands to show the image. If you show, we have defined this function here. Let's run it, and this function is now defined. Now we are calling that function by setting the title as colored image, and then we are passing the image that we have read in previous steps, right? Then we run this, and it will show the image and give the title as colored image. Here we see that now. Now these are some codes that will generate the random images using NumPy library. Okay. So here if you see random byte array, we are generating using os.urandom or unsigned random value, which is of 1,20,000 points. Okay, or byte array, random bytes. Once we are passing this, it will store that random bytes into this object, and then these bytes will be converted to an array of image, which will be then plotted here. So this will plot a gray image, okay, of 3 into 4, 300 into 400 pixels. Okay. So this array is nothing but converted into 300 into 400 pixels. Now the same array we can convert into a colored image, and since colored image is made of 3 channels or 3 colors, RGB, red, green, and blue. So that's why we are putting 100 as the size of red channel, then 100 as the size of blue, and 100 as the size of green channel. So that would be again 300, but 100 each for three different channels. So this is 300. And then the width will be again 400. So this will just print with the same width, but only one third of the gray image, because now that array is getting converted into three layers of red, green, and blue channel, which are of 100 pixels each. So total 300, but overlapping on each other here. Okay. So that's about how we can show monochrome or gray, black and white image, and then RGB image using a NumPy array. Okay. And these are just random arrays. So one could be white, one could be black here in case of a black and white image, and here one could be red, green, or blue. Either of these, each pixel will be there, right? Okay. Now we are also defining one function which is image save, where we can put the image name and which image to save, and that image object, the name of the image, will be retained to our current working directory, which is the same. So here we have our Google Drive connected to Google Colab to read the files from Drive, but the files that will be generated, it will save directly to this local directory and not within the Google Drive. So let's run this function. So this will define a image save function, and whatever the image that we have earlier read from our Google Drive, we can save it as an output.png. So let's run this. Here you'll see that file being written. If I refresh this, you can see one file is written here. If we just double click it, it will show within this sidebar what was the image. So this is the original image that we read from our Google Drive, and now we have saved that to this working directory, current working directory. Once we restart the runtime, all this image will be lost. So make sure to save this somewhere in case you need the images. Okay. So that's all for now in this session. In the next session, we'll start displaying the image dimension, how to change the aspect ratio, and other manipulation techniques on the image. Okay. Thank you. Bye-bye.